Hi everyone, this is Hw11 and this video is for homework 11 question 1. Okay, now let's take a look at this question. It said that the stochastic process xt is real Watson stationary and its autocorrelation Rxx tau and power spectral density Sxx omega show that its autocorrelation is real and even. Since xt is real Watson stationary, so we could, according to the definition, its autocorrelation is equal to the expected value of xt plus tau times xt. Because xt is real, so this is real and this is real and their product is also real, and so this expected value of this real function is also real, right? So xt, so its autocorrelation is also real. Now we need to prove it is even. This is equal to, we could also write it as t plus tau t, which is, as we write before, xt plus tau times xt. We could exchange those two items, so it equals the expected value of xt times xt plus tau, and this can also be written as Rxx t plus tau, right? So this is Rxx minus tau. So we could say its autocorrelation is even, right? Real and even. Okay, now let's take a look at the second question. It wants us to show that the power spectral density is even and non-negative. So again, according to its definition, this power spectral density is equal to this, right? So we could expand it as so we know that in question A, we prove that this autocorrelation function is even. So in this integral, this is even, and this sine function is odd. So an even function times an odd function is an odd, right? So this integral will be, since it is from negative infinity to positive infinity, so this integral equals 0, right? This equals 0. So this part can be removed. Since this cosine function is an even function, so we could write it as two times the integral from 0 to infinity, right? This is r12 cosine omega tau d tau. And since this cosine function is even, so we could rewrite it as right. So this is equal to hence this power spectral density function is even, right? Okay, now we need to prove it is non-negative. So we could suppose that this xt is an input, right? And the input to a system, and the system function is like this. Omega is between some omega 1 and omega 2. The value is 1, otherwise it is 0, right? Suppose. So we could find that this the expected value and output is yt. So the expected value of its output square can be written as this, right? So according to this system function, we could rewrite it as from omega 1, omega 2. Right, because if it is not between omega 1 and omega 2, it will be 0. So this can be rewrite as this form. Now we can see since this expected value of the output square is non-negative, right? Because this is non-negative, so its expected value is also non-negative. So we could say this is greater or equal to 0. So which means that for any omega 1 and omega 2, this integral will be non-negative. So if omega 1 and omega 2 are very, very close, this will be a point on this function, which means that any point that this function is non-negative. So we could say it's non-negative, right? It is even and non-negative. That's all. Thank you.